In looking at this section, we're going to be writing expressions, equations, and inequalities, and we're going to be starting from the English language and translating into mathematical language. So on the side here, I have a table with a lot of words in it. So these are all words that mean addition. These are all words that mean subtraction, multiplication, division, equals. These are words that you need to become familiar with. If you're a flashcard user, this would be an excellent use for flashcards. Put these words on one side and the mathematical symbol on the other side. And I know that there's some Quizlets out there that have things like this on it, but you need to get familiar with these words. You have to be able to translate these English language words into their math counterpart here. So we're going to look at some examples, and we're going to get into expressions and then get to equations and inequalities. We'll start small. We've got the difference of n and 6. Well, the difference of n and 6, in other words, how do we find the way of how far apart to go? Let's circle this keyword of difference. Difference means subtract. The quotient of k and 2. Okay, quotient means division. So the quotient of k and 2. So k divided by 2, or we could say k over 2. 6 less than g. Pause the video and write down what you think this is going to be. Okay, less than means subtraction, but we're starting with g and going 6 less than that. The proper way to write this is g minus 6. It is not 6 minus g. The order gets changed when we're going less than something. We're less than g. And then we get a little bit bigger. These are a bit more complex, no more difficult. So take a second, pause the video, and circle the key words in this first example right here. And if you're daring, circle the keywords down here. Circle those words that mean mathematical operations. So we have less than, and we have times. So for less than, that means we're subtracting 4 from something. So we're going to go minus 4. What are we subtracting 4 from? We're subtracting 4 from 6 times a number n. So 6 times n. 6n minus 4. In the second example on this page, we have the word quotient and plus divided by. So we have some important words here. We actually have 3 words, but there's actually only 2 mathematical operations. The quotient when the quantity 10 plus a number. Okay, 10 plus a number. 10 plus, what do we want to call the number? Let's call the number q. The quotient of that is, the quotient means what you get when you divide. So divided by 5. This whole thing is called a quotient. We're taking the quantity 10 plus a number and we're dividing it by 5. There we go. So this example is significantly more complex. There's a lot more words. And before we start to digest this, let's take a look at a problem-solving strategy that we have in mathematics called cubes. We're going to circle the keywords. We're going to underline the question. We're going to box the numbers. We're going to eliminate stuff we don't need. And then when we're done, we have to look at our answer and say, does that make sense? So this is very applicable to this problem. So let's go back and look at it here. So we want to circle the keywords, box the numbers. So let's do those 2 things right now. We have 5 other people. We have important words of equally. Write an expression for each person's share of the tips. So there's a lot of words here, but not a lot of direct mathematics. We have to understand what's going on here. But what we do know is that it's you and 5 other people. So what we really have are 6 people. We don't care about the fact that we're at an ice cream stand. We don't really care that they go into a jar, but we do care about the fact that we share them equally at the end of the day. Write an expression for each person's share of the tip. So verbal model. What's going on here? Well, we have a whole bunch of money in a jar. I'm going to draw a little picture here with money in the jar. And we need to split this evenly amongst all the people. So we can use a verbal model to help us think through this process. People sometimes find it easier to think about this problem using regular words instead of math words first. So the verbal model, we're taking the amount in the jar and we're dividing it by number of people. Right? That's how we would figure this out. We take all the money that's in the jar and we divide it amongst however many people there are. So our mathematical model would be, I don't know, some amount A that we don't know divided by 6. And A is representing amount in jar. And there we go. There's our mathematical model. Now we'll toss a few more words into the mix. We're adding in some words to our vocabulary that mean inequalities. So we have greater than or equal to, less than or equal to. And these words underneath each of them are words that we use in the English language to tell us about these inequality operations. These are ones you also need to get familiar with. So we have this problem, another big word problem. I want you to take a moment and try to use cubes. So circle the keywords, underline the question, box the numbers, eliminate what you don't need. We have $10 off, $17, 4 tickets. Those are the numbers. What is the regular price of 4 tickets? How much will each person pay? The fact that we're going biking is not important. It's us and 3 friends. We've already circled that there are 4 tickets, so 4 of us total. You had a coupon for $10 off. Off would be an important word. And I should have boxed these numbers instead of circling them. But $10 off is important. Paid would be important. So, and shared equally seems important. Let's go ahead and try to write an equation for this. Because you know what? This word paid, that's a word that's implying a total. Total amount, that's an equal sign. So the total amount that we paid is 17. And it's $10 off the regular price. So if we knew the regular price, which we're looking for, let's say R is equal to the regular price, how would we write the left-hand side of this equation so that that's finding us the new price, that it's finding us $10 off the regular? Well, it's going to be R minus 10. And we can use a little bit of our mental skills here and know that R would have to be $27 if we're paying $10 off. And now we have a second question. If you pay the regular price and share it equally, how much will each person pay? Well, we're dividing it equally amongst 4 of us. So what we're doing is we're doing R divided by 4. In other words, 27 divided by 4, which gives us $6.75 per person. And have I answered the 2 questions? Yeah, I've answered 2 questions. I've answered the question, what is the regular price? It's $27, and that is $10 more than I paid with my coupon. Does that make sense? And paying $6.75 each is the answer to the second question, and that's less than the $27. And we could check to see if we're right by multiplying our answer by 4, but our answers do make sense. So we are good to go. We used cubes to help us digest. Onward. Last thing I want to look at is I want to talk about solutions to equations and inequalities, and a value for the variable that keeps the statement of equality or inequality true is something that we call a solution. So I have an example here. Is x equals 2 a solution to 2x minus 1 is less than 6? Well, what we're wondering here is if I take 2 and put that where it says x, does this inequality remain true? So what we can do is we do 2 times 2 minus 1. We don't know if this is true. This is what we want to find out. So we take that left-hand side and we're going to evaluate that left-hand side. 2 times 2 is 4. 4 minus 1 is 3. Is 3 less than 6? Yes. So is x equals 2 a solution? Yes, it is. The way we can check to see if numbers are solutions to equations or inequalities is by substituting them into the variable and evaluating the two sides of the equation or inequality and comparing them to see if they're equal or less than or greater than or whatever the problem is asking us to do. And this is where I shall leave you. I hope you enjoyed the practice problems that I will be providing.